And our final speaker from the panel of scholars invited to speak this evening is James Kilner. James is Senior Lecturer in Human Motor Neurosciences at University College London, and his current interests include research into human social interaction, specifically upon our ability to infer beliefs and intentions into other minds. And James is also widely published on a range of issues concerning neuroimaging and the science of perception and action. Welcome, James.
Yes, I feel like I'm kind of a stranger in the midst. I don't know anything about photography. But what I'm going to try and talk about is really the processes that happen inside our brains when we look at images. And those images could be of other people. There's obviously a shared overlap in between looking at images of yourself, or myself here, or of somebody else. So really what I'm going to try and do is trying to look inside here and see, or try and tell you a little bit about what might be going on inside our brains when we look. I should say that I am very eager to collaborate with anyone who might be interested in anything I say, which is why I put this here. I'm also on Twitter, but this comes with a slight health warning that this is the first time I've given a talk in probably a decade that doesn't have equations. So a lot of my tweets are pretty incomprehensible. So if you do decide to follow me, I apologise in advance. So really what I want to try and do is try and take the lid off and kind of have a look about what's going on inside. So as I said in the introduction, my work is really about how we are able to understand other people through non-verbal social communication. So what this really means is that we make movements, we make facial gestures that we all know we're able to understand. We know we're able to understand them and draw information out of what other people do. My research is all about what's going on inside our brains that enables that to happen. So what I'm going to try and do very briefly is trying to go through some bits to deal with what's required when we look at a picture to try and understand it. So obviously fundamentally we have to recognise that it's a face, and we have to kind of recognise potentially what emotions are being presented to us, what emotions are present in that face. There's then the possibility of basically having recognised it's a face and what the emotion is, having some kind of empathic response to what it is we've observed, and then maybe trying to extract some kind of higher level idea about what we think this person might be doing, so kind of some higher features of the perception or meaning behind what the person might be doing. So that's what I'm going to try and do very briefly. So for those of you who may not have seen a brain before, it's here. So basically the most important bit for the purposes of this talk, and I'm not going to go through what the whole brain does, is that this bit here primarily does stuff to do with vision. So I'm going to talk about it because the images we're looking at are going to be visual images. So this, if you like, is where the input does. So even though the eyes are here, this is the bit of the brain that does vision. And the other bit I'm going to talk about is this kind of part here, which is part of where our senses come from and how we control our movements. So one easy way to think of this is to say, well, clearly what happens is that the visual bit comes in and then we process it through some kind of networks. These are not literal, that please don't come away with the idea that this is how the brain works. But basically we have a starting point of vision and everything else kind of projects forward from there. So if we look at recognition of faces, then it's clear that we can have a very good model of what a face looks like. And we are experts at recognising faces. In fact, we've become so good at it, we've probably all had the experience of recognising faces when there isn't a face present, like in formations of clouds or whatever else you want to do. And this has been aped in technology as well. So as we get to face recognition technology, that also has become so good that it recognises faces when they're not present. So I was very pleased that one of the people who put in this, Andrew Bruce, put in examples of this as his submission to the competition. So this is really saying, so again, harking back, technology is kind of is mirroring what we do ourselves. But really it's kind of easy to show that that isn't really the case. So if I show you an image of myself, this is an image of me, and you might be wondering why I've shown it to you upside down. And this is because you will look at this and you'll say, well, that's just a picture of me, that's fine. But if I turn it the other way up, it's been photoshopped so the eyes are actually the wrong way up. It's very hard to detect that if it's upside down. it's very easy to see it when it's the correct way up. So I promise you this is the same image. All I've done is rotated it. So what this is saying is that, at least in part, bits of our brain that are processing this are not just taking the visual information and processing it, because it's exactly the same visual information in these two images, but we have a very different percept of what's being presented to you. So really this is just showing you that it's not just simply enough to say we process the visual information and that goes up through the system and everything else follows. In part, we have a kind of expectation of what we think a face should look like, and we put it on. And the thing is, we have much more experience of looking at faces this way up, and so we interpret it slightly differently. Now, a lot of cognitive neuroscience, particularly in the visual domain, uses visual illusions to show this very dramatically. And in searching for images to present here, I was really pleased to find this visual illusion. I find this a really amazing visual illusion. So I'll give you some time to look at it, because I think it really is amazing. So this is a conjoined photograph of someone in profile and someone face on. And you should be able to flip in between the two. And it actually becomes really quite disturbing to look at, because you can't really fixate on one or the other. So this is saying that we're basically fitting our own ideas of what the face should be, whether it's a frontal view or a perception or a profile view, onto this image. And that changes quite rapidly. So it actually becomes very hard to settle on which the correct representation is. So this is really all just to show you that everything isn't just, you don't just feed in the visual information and everything else follows. We have a lot of our brain that has an idea of what we think we ought to be expecting that influences our percepts. So it was Gustave Flaubert who said, there's no such thing as reality, there's only perception. So this is really trying to get at the idea that there isn't really anything out there. What we see, what we experience, is completely clouded and masked by our own experiences that we've had through our lifetime. The next thing I was talking about is recognition of emotions. Now, it turns out that facial expressions or representations of emotions are universal across humans. So this was something that Darwin wrote about, and I was also very pleased to see that one of the entrants, Meg Mosley, had these nice examples of different selfies producing different emotions. So it's very easy for us to look at this and try and make an estimate of what the emotion is that's being seen. So this is again something that's very simple to understand. Now, when we look at images, you might think of this as just a visual process, but it's been well documented that if you take the muscles in the face, this is just a very old picture of the muscles in the face, that when you look at someone smiling, you automatically imitate that smile. Your muscles in your face will contract so that you produce a smile, a very small smile. And similarly, if you're angry, you'll produce a frown. If you're looking at an angry face, you'll frown. Now, it turns out if you ask people to try and do recognition of emotions while holding a pencil in their mouth, i.e. stopping the muscles changing, people are much worse at being able to do this. Now, this is really one of the major differences, and I'm going to come on to this in a bit, in between looking at yourself versus other people. So we are experts, as I say, at visual recognition of other people. We have little, and I would perhaps even argue no, proper visual knowledge of what we look like. It's very, very poor. We sense ourselves and our faces by how we move. So if I'm happy, I have a feeling of what my face would look like. So people have proposed that through this kind of automatic imitation mechanism, we can actually quite literally feel the emotions that someone else is presenting to us. And this has a way in which we can actually have some kind of empathy, quite literally feeling their emotions ourselves. Now, this process means to say that it's not just the visual system, that we use bits of our somatosensory system, this kind of input from our muscles, and our motor system of activating those muscles to help us in terms of how we interpret images. And there's a large body of research, and in fact my entire research field is on the involvement of the motor system in understanding other people's non-verbal social intentions. That's what I do. So coming back to the selfies, what I was saying earlier is that we have a very poor representation of what we look like. So what we have when we take a picture of ourselves is that I have a representation when I take my picture of myself of what I think I look like. I then take the picture and I look at it, and I'm going to see whether this matches what I think I look like. Now, we have a very bad visual representation. So you might think we'd be very bad at doing this, and we are very bad at doing this. We're very bad at being able to produce. If I ask you to imitate, if I give you a picture of yourself smiling and I ask you to imitate it, you are very bad at it, even though it's you producing the same action. That's because we have very poor visual feedback of what we look like. But we're very bad at this, but we're not just very bad at it. Unfortunately, there's a slight bias which is slightly tragic, which is that we all think that we are slightly younger and slightly better looking than we actually are. And so there are some very interesting examples of this. So there's a particular patient who had a deficit in actually understanding mirrors. So understanding what was being presented to them in a mirror. And when he was talking to his clinician about this particular problem, he was saying, well, what happens when you shave? And he was saying, well, it's interesting because when I go and shave, I stand there and someone appears in front of me and seems to do exactly what I do at the same time that I do it while I'm shaving. And they said, well, do you not think that could be you? And he said, well, there are similarities to me in this person, but the person is much older and not as good looking as I am. Now, although I've presented this in quite a jovial way, it's also quite poignant because obviously we change through our lifetime. And I particularly like the work, and she can't be here today, of Carly Clark, who took a series of photographs of herself during her treatment for Hodgkin's lymphoma. And in the bio she accompanied these photographs, she was talking about her motivation for doing it was to be able to have some kind of representation of who this alien person was that she had become through the process of the treatment and of the disease itself. So I think there's an idea that we really don't really know what we look like. Now I'm going to end by putting these photographs back up. But one thing that strikes me about selfies and potentially why they have become so ubiquitous and why we have potentially taken to them so easily is that for me it's a perfect marriage of two different things. One is the technology, which basically allows us to keep taking a photograph until we get to the point where we think we look like what we think we look like. But not only that, we then have a platform to be able to maintain our reputation of what we want other people to think we look like. In other words, we can upload them so that we can share these with lots of other people and say, look, I really do look this good. I don't look as bad as all the other photographs say that I look like. So as I say, this is how to contact me if anyone's interested in anything that I've said. But thank you very much.
That was fantastic, James, and it's great to know that there's actually a science behind that idea that we all think that we're better looking than we are, and it's something, neurological, not just social. So that's really interesting.